Let's look at another example. Suppose I want to evaluate this. Sine of 2x. Okay. So now this is very similar to the one we have on the integral formula list, but notice that we have some subtle difference here. Okay, and this subtle difference is not small, it's actually pretty big, because if you were thinking this, I'm gonna use a gray, okay? If you were thinking, saying, oh, from the formula I know the antiderivative is equal to negative cosine x plus c, hence by mimicking the procedure, and then you said this should be minus cosine of 2x plus c. If you were thinking this, then the answer is no. Why? Because if I go ahead and differentiate cosine of 2x plus any constant c, then according to the chain rule, I will have minus sine of 2x times 2. This 2 is coming from taking the derivative of 2x. Alright? And then plus 0. This 0 is coming from differentiating the constant. Okay, so simplify this. I'm getting 2 sine of 2x, which is not exactly what we have inside the integral. Alright? So you cannot just go like, oh, this is similar to what we have on the integral formula, and then you kind of create your own generalization. It does not work this way, so be very careful, okay? So this is wrong, then what do we do? All right, once again, you're gonna supposed to see that this is a composite function. Okay, so the outer function is y equal to sine of u, and the inner function is u equals 2x. Right, okay, so we're gonna use the inner function to help us. Okay, so I'm gonna say let u be 2x. When you have this, you go ahead and compute the differential. So the equation is 2 du equals the derivative of 2x times dx. So derivative of 2x is equal to 2. So we end up having du equals 2 dx. So this is saying dx is equal to 1/2 du. You divide the equation by 2. Alright, so if you do so, then the given integral now is equal to sine of u, and dx is 1/2 du. So you end up having 1/2 integral of sine of u du. Antiderivative sine is equal to negative cosine, so negative cosine of u plus c. Then again, you need to write everything back in terms of x. So u is equal to cosine 2x. Alright. So now you can see that if you perform the u substitution, you will end up having this 1/2 to correct the antiderivative, okay, versus before. So similarly, let's look at another example. If I have e to the 3x, let's say 3x plus 1 dx, then this is again a composite function with the outer function exponential function and the inner function as u being 3x plus 1, right? Okay, so we don't really need this. This is for our own observation. Let me change the color. Okay. All right. So we're gonna use this as our inspiration and then say, okay, I'm gonna let u to be 3x plus 1. All right. Now you compute the derivatives. You have du equals the derivative of the function you have times dx. So this is telling you du equals 3 dx. That is saying dx is equal to 1 over 3 du. Divide the equation by 3. Alright, so now go ahead and do the conversion. E to the 3x plus 1 dx equals e to the u. And dx is 1/3 du. So you end up having 1/3 e to the u plus c. And then you remember you need to write u back to x. So there we go.